Okay, we're going to start today with a warm-up on triangle trigonometry. The first question asks how long the tunnel is, as well as how deep the tunnel is. So we're going to answer the first question, how long is the tunnel first. So in the diagram, the tunnel is labeled, goes through the mountain, so it's going to be the distance from A to B here. So we've got this triangle, and let's determine the information that we were given. So we're given this side here, 3,800 meters, and this side here, 2,900, and the angle between them. So that's our side angle side pattern, which means that the cosine law can give us the length of the opposite side. So since this angle is labeled C, we could call the opposite side little c, and that would end up being the length of our tunnel. So we'll start off. C squared equals, this is the cosine law, a squared plus b squared minus 2ab times the cosine of angle C. Actually didn't need to write the formula out, but it's a good review from yesterday. Now we can substitute in. So in our case, little a happens to be 2,900 squared plus 3,800 squared minus 2 times 2,900 times 3,800 times the cosine of the angle between them, which is 110 degrees. So some of you will be able to go straight to the length of side C. Some will still use this middle step where we find C squared on our calculator. So I'm typing in 2,900 squared plus 3,800 squared minus 2 times 2,900 times 3,800 times either 110 cos or cos 110, depending on your calculator, equals, and I get a very large number, so 30,388,123.96, but then we're going to square root. So the length of the tunnel is approximately 5,512.5. 5,512.5, and that's meters long. So we can answer the first part of the question. Therefore, the tunnel is 5,512.5 meters long. The second part of the question asks how deep the tunnel is. So it's wanting to know from the deepest point of the tunnel, that length there. So we're going to assume that that length is perpendicular to the tunnel, so that we have a right angle triangle there. But other than the right angle, we don't know either this angle or this angle over here. We don't know, so we could either look at this right angle triangle here or this one here in order to get how deep the tunnel is. So the first thing we're going to have to do is find either angle A or B. So I'm going to just choose to find angle B. And if again I look at the whole triangle that I'm outlining in yellow highlighter here, I can apply the sine law to the large triangle in order to find angle B. So when I'm finding an angle using the sine law, I start off with the angle on top, so it's the sine of the angle over the length of the opposite side is equal to the sine of the angle we know, which is 110 degrees. So sine of 110 degrees over the length of its opposite side, which is that length that we just found. So 5,512.5. So to get the sine of angle B by itself, we would multiply both sides by 3,800. And now we've got a number that represents the sine of angle B. And it wouldn't be a perfect number, so we could just leave it and let our calculator do the work for us. But that's the sine of angle B, and we just want plain angle B. So hopefully we're learning that to get angle B, then I would have to take the sine inverse of both sides, but we can just show it as angle B is the sine inverse of 3,800 times the sine of 110 degrees divided by 5,512.5. And then if you enter that into your calculator, you'll be able to get angle B. So this is kind of like the first step in finding out how deep the tunnel is getting that angle B. So depending on your calculator, you might have to do the inner part of the bracket first and then shift sine, or you may press shift sine first and then will open a bracket for you, and you can type in 3,800 times the sine of 110 degrees divided by 5,512.5.
Your voice is dropping off.
Okay, thanks. So that gives you approximately 40 degrees. So that means our angle here, B now, is 40 degrees. And now I can work within this right angle triangle in blue here. So according to the 40 degrees, I'm trying to find the opposite side here, which I could call X. And I know the side across from the right angle, which is the hypotenuse, is 2,900. So I want to find the opposite side, X, and I have the hypotenuse. So the trig ratio or formula that I would use, step 2 here, is sine, because sine is the opposite over the hypotenuse when you're working with a right angle triangle. So the sine of 40 degrees is equal to the length of the opposite, which we're trying to find, X, over the length of the hypotenuse, which is 2,900 meters. Right, and the calculation. Okay, so then you're going to multiply both sides by 2,900 to get X by itself. And then you get that X is approximately 1,864.108, but rounds to 0.1 meters. And then again, therefore, the tunnel is about 1,864.1 meters deep. Okay, so that was a two-part question. First part involved using the cosine law to get the length of the tunnel. To get how deep the tunnel was, we needed to use the sine law to find an angle. And then we had a right triangle where we could use SOHCAHTOA to get how deep the tunnel was. Okay, the next question. Similar to the airplane question we talked about yesterday. 2 ships leave a harbor at 1 p.m. One ship travels at 25 kilometers per hour northwest, and the other travels at 40 kilometers per hour in the direction north 32 degrees east. How far apart are the ships at 3 p.m.? So again, we're going to start by drawing a diagram. And this is going to be, up is going to be north, down south, right east, and left is west. So one ship travels at 25 kilometers per hour northwest. So if there's no degrees given between north and west, we assume it's at the 45-degree angle. So try to make it look like it's halfway. The other one travels faster in the direction north 32 degrees east. So that's a bit closer to north than east, but it's going to go farther because it's traveling faster. So how far apart are the ships at 3? So from 1 p.m. to 3 p.m. is 2 hours. So the first ship went 25 kilometers in 1 hour, so in 2 hours it's going to go 50 kilometers. The second goes 40 kilometers in 1 hour, so it's going to go 80 kilometers in 2 hours. And then we want to know the distance between them, so that we'll call that little d here. So we've got 2 sides. We must have an angle somewhere. So the way we get the angle is by knowing the first ship travels northwest. We know between north and the path of the first ship is 45 degrees. And the second one travels in a direction of north 32 degrees east. So north 32 degrees towards east here. So then that gives us a total angle between the paths of the two ships of 77 degrees, 45 and 32. So 77 degrees. All right, so again, we've got this pattern of we know a side, we know the angle between the two sides, and another side here. So we've got side, angle, side, so we can use the cosine law to find how far apart the two ships are. So that distance squared is going to be 50 squared plus 80 squared minus 2 times 50 times 80 times the cosine of 77 degrees. And then we can find that out on our calculator. And I get approximately 7,100.391565 before my calculator runs out of giving me digits. And again, some people sometimes forget to square root, but you have to ask, does your answer make common sense? So one travels 50 kilometers and one 80 kilometers. Are they going to be 7,100 meters apart? That doesn't make any sense. So hopefully that would prompt you to realize that you hadn't square rooted both sides yet. And you end up getting 84. And let's see, it doesn't say to the nearest kilometer, so 84.3 if you round kilometers. And that makes a lot more sense. So therefore, the ships are 84.3 kilometers apart at 3 p.m. So that concludes our warm-up on trigonometry, and we will you can go to the next video and we'll talk about three-dimensional trigonometry.